Hello everyone, this is Adnan and welcome to Chemistry with Adnan. On this YouTube channel, I'm covering the entire syllabus of IGCSE Cambridge Chemistry, and the course code is 0620. I also own a community on school.com with the name of High School Chemistry, where you can join for free. You can ask questions, you can participate in discussion forums, and there I offer a free lesson once in a month where you can interact with me live. You can ask me questions, and I also offer one-on-one lessons and group lessons, which are the paid packages. So I offer 4 lessons in a month, once per week, just for $20, which is really economical. And if you need one-on-one lessons, the seats are very, very limited. And yeah, you should go check it out. The link is given in the description. Okay, so now in this lesson 7.3, we are covering preparation of salts. So this topic, this chapter, or this particular topic is one of those topics where students make most mistakes, and they struggle understanding this. So like whenever I have one-on-one lessons, and when we reach this topic, so the students, they really want to emphasize on this topic, and they really want to learn this. And this is where I find huge knowledge gaps, and students don't understand it well. So I will try my best to explain it as much as possible. And in the upcoming lesson, we will be covering the past paper questions, specifically based on this topic, preparation of salts, right? So the first topic is for both the core and supplement students. So the first topic, it says that describe the preparation, separation, and purification of soluble salts by reaction of acid. So what are we reacting? One of the reactions is acid, right? So we can make a soluble salt which is soluble in water, which means that when it will be formed, you will not be able to see it. You have to retrieve it from water, right? So I'll explain it in more detail in a minute. So the first method that we will be looking at is an alkali by titration, right? So an alkali. So what is meant by an alkali? In the previous lessons, we learned that alkali is a soluble base, right? Soluble base with a pH of greater than 7, right? It has a pH of greater than 7, and it releases hydroxide ions, or it is a proton acceptor and stuff like that, right? These are the definitions of a base or an alkali. A soluble base has a special name, which is called an alkali. Okay, so why we are using titration, this method, and why we have excess, the word excess being repeated, with other methods of producing soluble salts. So this is something where students, they don't understand well. So I must explain it, right? So acid can be dangerous, right? So you make sure that when you are dealing with acid, or you are using acid as a reactant, so you make sure that all of it is reacted completely, right? So for example, let me give you a word equation. So let's say hydrochloric acid, for example, hydrochloric acid, reacting with an alkali, which is, let's say, sodium hydroxide, right? So sodium hydroxide. So they're gonna produce salt, sodium chloride, and water, right? So yeah, so you can see here that this is the acid we are using, and that's an alkali we are using, right? So they're going to produce sodium chloride and water. So how do we carry out this a reaction? So we use a burette in which we put acid, and we use a conical flask where we put our alkali, right? So HCl will go, hydrochloric acid into the burette, right? And sodium hydroxide, which is an alkali, it will be in the conical flask. We put an indicator, and indicator is something that changes color when the end point is reached, when the neutralization reaction is achieved, right? By neutralization, I mean when all of the acid that we are pouring in this one, it will completely neutralize. So H plus ions and OH minus ions, they will be the same at the neutralization point, right? So this is why we use titration. Yeah. So now this salt that has been produced, so we pour this into an evaporating dish, and yeah, so in this beaker we will have this NaOH will convert into sodium chloride, right, after reacting with HCl, and the products will be sodium chloride and water. So now we transfer this into an evaporating basin, and we start heating it, right? And we evaporate most of the water in which this salt is soluble, right? And after evaporating most of it, we leave some for to dry, to cool down, right? And since most of the water has been evaporated now, so the salt that was soluble in this volume now cannot remain soluble in a small and in less amount of water, right? So it will start to crystallize out, and then so the first step is evaporate it, or heat it, right? So heat, and then allow it to cool, and then filter it. When crystals appear, you filter it, and then you wash the crystals, and then you finally dry. So that's the process, right? So step one, heat it. Step two, allow it to cool down so that the crystals can appear. Once the crystals appear, you filter the solution, and then after filtering it, you wash it, and then you try it, right? So sometimes you see a 5 marker question on this, sometimes a 4, sometimes 3. So this is very important. The sequence is very important, right? So you must not forget this. Okay, so I hope this is clear, that how we get a soluble salt, by how do we prepare it, how do we separate it, and how do we purify it by reacting an acid with an alkali by titration. So the next method is excess metal, right? So now let's say we are using a metal, so lithium, for example, right? So lithium, so this is B, second method of producing a soluble salt, right? So metal, lithium plus and acid. So let's use nitric acid. Right? So nitric acid. So now they are gonna make lithium nitrate, lithium lithium nitrate, and hydrogen gas, right? Remember, we studied in our previous lessons that whenever metals react with acid, they produce salt and hydrogen gas. Remember that, right? So this is the word equation. So I'll also write the symbol equation. So lithium solid, upon reacting with nitric acid, which is aqueous, right? And it is going to produce uh, lithium nitrate, LiNO3 plus hydrogen gas, right? So the equation is not balanced. I'm going to balance it. So I'll have to put 2 here, 2 here, and 2 here. Yeah, now the equation is balanced, right? So yeah, so now uh, so the same thing, let's say we have acid in the beaker, right? And now we add lithium into this acid, right? So we will keep on adding it until it stops disappearing. That will be the point where all of the acid in the beaker will have reacted, right? This is very important. What I'm about to do, I'm discussing right now. This is a very important point, and you must try to understand it. That why lithium must be in excess, because we need to make sure that all of the acid that is in this beaker, has reacted completely with lithium. And how will we know that? When we will put more lithium, and it will stop reacting, right? It will be just floating on the surface of water, and it will not be reacting anymore with this, because all of the acid, by that point, will have reacted, right? So this is very important. So now what you need to do now, let's see what do we have in the solution in this beaker after the reaction. So we have uh, you know insoluble insoluble excess metal, right? Floating here. And we also have like soluble salt, so in the form of lithium plus and nitrate ions, right? And the hydrogen, it has evaporated. So now, yeah, let me just try it like so. The first method, for retrieving the salt from something, like from this reaction, will be filtration. First, we need to filter, we need to separate the liquid from the solid, right? Which solid? The excess metal, which is insoluble, which is not reacting with the acid, because there is no acid remaining, right? So this order will be different from this one. So that is why, like these small differences, they make this chapter or this topic confusing and difficult. So you must understand that what should be the sequence of preparation and separation and purification, based on what method we are studying, right? So now first here, we filter it. Step one, filter. Now, after filtration, we have this soluble salt in the beaker, which is lithium and nitrate, right? Now, the rest is the same. Now we heat it. Now we transfer it to the evaporating dish, and then we heat it, right? So we remove some of the water which was present initially in this acid. This acid was basically diluted, and it was dissolved in water. You may say that, since we are not getting any water as a product, so where did water come from? So it was already present in this acid, right? So now that water, you have to evaporate most of it, and after heating it, right? So uh, step two, heat it. And then when very small amount of water remains in the evaporating dish, so you allow it to cool down. And as you will allow it to cool down, the crystals will appear. So why does crystals appear? Why does crystal appear at this point? Because the amount of water is too small to keep them in the soluble state, right? Keep the salt in the soluble state. Now, after heating, step three is now you filter it again, right? And after that, you the same sequence. Wash, and then you leave it to dry. So you can also use an oven to dry, right? Or you can just leave it to dry on the shelf, right? So I hope this is clear. So what you need to understand here, that why lithium is in excess, it must be in excess, right? So that all of the acid, it reacts, and it completely changes into the products, right? So I hope this is clear. Now we move on to the next one, excess insoluble base. Yeah, so the same thing basically. So uh, excess base or excess insoluble base, It's the same thing because we have a different name for a soluble base, which is alkali, right? Uh, so this method is basically the same as reacting a metal, excess metal with an acid. So we again, let me see, let me write it here, explain it here. So see, here we will be using excess insoluble base. For example, magnesium oxide, right? It's a metal, and remember, metal oxides are basically basic in nature, and these are insoluble, right? So solid plus, now let's use hydrochloric acid, HCl, and they're gonna make magnesium chloride, MgCl2, which is soluble, and it's gonna make water, H2O, right? So now, how do we retrieve this, right? So let me write the straight state symbols. Yeah, okay. So the same thing, we keep on adding magnesium oxide into this beaker, till the bubbling stops, which will indicate that now all of the acid that was present in this beaker has reacted completely now, and the excess magnesium oxide, it will start forming a precipitate, right? So this is not the salt, right? Remember, we are trying to retrieve a soluble salt, so which you cannot see. So soluble salt, it will be in the form of ions, Mg2 plus and Cl minus, right? So again, the first step will be to filter the excess, a magnesium oxide that is settled down at the bottom. So the step one is filter, and step two, again, transfer it into an evaporating basin and evaporate most of the water, allow, and then allow it to cool down. So heat it. Step three, cool, allow it to cool down, and in this process, crystals will appear. And step four, wash the crystal, or filter. Yeah, filter, wash, and then number six, dry, right? So I hope this is clear. And now we move on to the third one, the fourth one. Yeah, the fourth one is insoluble carbonate. So metal carbonates, they are also, they are also classified as bases, and yeah, because their pH, their solutions, they yield a pH greater than 7. So the same thing, you use a beaker with a certain acid. It may be HCl, it may be sulfuric acid, it may be nitric acid. Nitric acid gives you nitrate salt, right? And sulfuric acid gives you sulfate salt, and hydrochloric acid gives you a metal chloride salt, right? So let's use sulfuric acid this time. So, and insoluble carbonate, right? So a metal carbonate that is insoluble uh, in like that is insoluble. So we keep on adding it, right? So we keep on adding uh, until the bubbling till the bubbling stops, and it will make for the excess insoluble carbonate will form a precipitate. And then the first step again in this one will also be to filter, right? And then you heat the remaining mixture, and then the third one is you allow it to cool, and then the fourth, in this process, crystals appear. And this step, the crystals appear, and the fourth step is filter, and the fifth step is wash, and the sixth step is dry, right? So this was our lesson. So this topic is a bit lengthy. Now we have solubility rules, which will be covered in the next one, right? And then for extended, students describe the preparation of insoluble salts by preparation. Yeah, so these two topics, topic number 5 and 6, I believe, they are from the extended syllabus, right? So these will be discussed in our upcoming lesson. So there's a playlist dedicated to IGCSE Cambridge Chemistry 0620. Yeah, you can share it with your friends. You can like, subscribe, and share. And yeah, don't forget to join my community on school.com, right? So I hope I'll see you in the next one. Take care. Goodbye.